On April 7th in 2001, NASA launched a 2001 Mars Odyssey mission named in reference to Arthur C. Clarke's sci-fi classic 2001: A Space Odyssey. Odyssey was a Mars orbiter mission, which means it would stay in orbit around Mars to scan the surface. It followed on the heels of two failures for NASA. First of all, and most remarkably, the Mars Climate Orbiter. In 1999, of course, it was lost due to a software mishap, which produced output in pounds seconds instead of the international Newton seconds, and that failure of units caused the craft to disintegrate in the Martian atmosphere as it aimed too low in the atmosphere for its aerobraking. Then NASA also lost the Mars Polar Lander in the same year, and so this mission, 2001 Mars Odyssey, was a bounce-back mission for NASA, trying to recoup after those two serious failures. Now you'll note that Mars Odyssey, which you see here, looks a lot like the Climate Orbiter, which failed, but that's mainly the bus, the center portion of it. The actual instruments were different. In fact, Mars Climate Orbiter's mission would be fulfilled by the Mars Reconnaissance Orbiter later. So this wasn't actually a direct replacement for Mars Climate Orbiter, but it was important that this should succeed, otherwise NASA's image would be, lost forever. Odyssey had four main instruments. The first was the High Energy Neutron Detector HEND. The second was the Mars Radiation Environment Experiment, MARIE. I don't know how they got the I there, but anyway, they call it MARIE. And the most obvious one is the one on the boom. That's the gamma ray spectrometer that you see sticking out in front. But the one that interests us most, perhaps, is THEMIS, which is the Thermal Emission Imaging System, which is what took pictures of Mars. And a lot of the Mars pictures you see actually come from this little camera. And that we'll talk more about the images that we received from this later in the video. For now, let's turn to the launch, and the launch commentary for this launch was spectacular, so I decided to just go with the launch commentary as it happened in 2001. So here we go.
1. We have ignition and liftoff of a Delta II rocket carrying NASA on an Odyssey back to Mars.
Stage system's looking good. Load release kick rate is in. Vehicle is responding. Reset. Vehicle's working its way through the liftoff transient. System's looking good. Approaching Mach 1. Usual attitude disturbances through the thick atmosphere and the Mach buffeting. We are now supersonic. Controls and reactions settling down a little bit as we are in the supersonic range. We're now approaching max Q. Stage systems still look good. There it is. We passed max Q. Vehicle response is normal. Things are really settling down on the verniers. Solid motors beginning to tail off. T plus 60 seconds. Ignited the air start motors and jettisoned the ground starts. All 6 solid motors have been jettisoned. Looks like a clean separation. The usual reaction on the vehicle at the first stage when we separate the motors, it's being damped out. As expected, we are now at an altitude of 12 nautical miles, downrange distance 32 nautical miles, and a velocity of 3,200 miles an hour.
Real-time telemetry details are being called out by Boeing's Mark Levine from the telemetry lab, confirming all 6 boosters having separated. Excellent pictures of the launch vehicle as it departs the Earth.
Sequencer. You regular at T plus 110 seconds. First stage systems continue to look well. All solid motors are starting to taper off. The air start motors, as expected. Thank you. Beginning to burn out there. Okay, we have had burnout of the air start solid motors. Separation. Solid motor jettison. T plus 148 seconds into the mission. First stage systems continue to look good. We have reset the LOX tank pressure. pressure slowly increasing as designed. Vehicle continues to climb out through the center of the range track, and we are now at an altitude of 40 nautical miles with a downrange distance 136 nautical miles and a velocity of 7,200 miles per hour. Stage 1 guidance is in. Up on T plus 200 seconds. First stage continues to perform normally. Controls have really settled out now. Very nice and smooth up there at the upper stratosphere as we climb out of the gravity well. Passing T plus 225 seconds. Main engine is now producing a thrust of a little over 230,000 pounds as we continue to climb up through the thin atmosphere. Next mark event will be a MECO coming up in approximately 20 seconds. Stage electrical systems look good. Our stage performance still looks good. We have our fuel float switch, followed by LOX float switch, and we have enabled MECO, and there it is. Main engine has cut off. Verniers still looking good under tank pressure. Two good verniers. And there's MECO.
QAM on 1.
Stage 103. 1-2 SEP. We have separated the stages.
Go ahead.
You get and there's second stage ignition. Second stage is up and running. Pressure looking good.
Okay, copy that. Want to make sure. Thanks.
Thank you.
Okay, we have unlatched and jettisoned the ferry. 185 seconds.
Alright, so that's it for the original commentary. Probably best that I cut out there because this second stage goes on for another 6 minutes and we need to condense things a little bit. But excellent commentary there, of course. And here we proceed with the Delta K stage, the second stage of the rocket, an AJ-10 118K burning with 43.6 kilonewtons of thrust. And it brings the probe as well as the third stage into orbit. The third stage is the stage that gets it to Mars, and that is a solid rocket booster, a Star 48B, that burns for 87 seconds with 66 kilonewtons of thrust. It's also known as the PAM-D stage. And unfortunately, I cannot aim things quite right so that I can use a solid rocket booster to get a probe to Mars. I don't have that great aim or calculation ability. So as we separate off the second stage, a little bit more explosive than I intended for it to be. Here is the probe in the PAM-D. I think I'm missing the exact look of the propulsion module that the probe has. But anyway, let's pretend that the PAM-D has finished burning, because I really can't do that burn accurately in this simulation. So let's separate this, and now we have the probe. And we can extend the solar panels. You'll see its main antenna. I've got the gamma ray spectrometer already extended. That's actually because of simulation purposes. It's serving as an antenna. But anyway, solar panels out. Actually, interesting enough, the Odyssey does have reaction wheels. It has 4 flywheels, 3 required and then 1 redundant. Actually, the redundant one was necessary because one of the flywheels failed. But anyway, so those help maintain stability, and you can see them doing so as the solar panels rotate to face the sun. And yep, anyway, it looks all configured for its trip to Mars. Alright, so let's talk a little bit about its approach to Mars. And for that, we'll have a little graphic here. So it arrived at Mars on October 23rd. That's Eastern time. It's the 24th if you go by GMT. And there it did a 21-minute Mars insertion burn. That's orbit insertion with its 660 Newton rocket that has on its tail. And so that was used to bring it into orbit. And then it aerobraked into further lower orbits until it got into its mapping orbit, which is much lower. And you can see 400 kilometer altitude, and most importantly, a 93.2 degree inclination, or thereabouts. It's been adjusted since. Obviously, the high inclination, the polar inclination really, is so that it can map the surface, and it's a sun-synchronous orbit that it has. So it goes over most points on Mars' surface twice per day and has good daylight, good lighting in order to scan the surface, take pictures, and all of that. And it's still fulfilling those functions after all these years. It's the longest serving spacecraft at Mars, the longest surviving continually active spacecraft in orbit around another planet. It has proven to be quite the success for NASA after those 2 dramatic failures, and as we see in the simulation here, it did not go too deep into the Martian atmosphere in aerobraking as the Mars Climate Orbiter did. No, it survived, and it has survived for a very long time. What you see here now is a NASA JPL video that details the achievements of Mars Odyssey. Here you can see Odyssey becoming the longest operating Mars spacecraft there. It found evidence for frozen water, and subsequently we sent missions to confirm frozen water on the surface. You can see some of the images that Odyssey took of the surface, and we'll get a better look at those later. Its mapping of Mars using Themis, of course, helped NASA to find locations to land the landers, the rovers, including Opportunity, Spirit, and of course Curiosity. And it also served as a communication relay for Opportunity and Spirit, so it has been sending information from those rovers back to Earth for all this time. It continues to send information back from Opportunity. Now Themis is a thermal emission imaging system, so its images are all in grayscale. They look like this actually originally, and so NASA has to add a false color to it based on other sources. Of course, they can determine what color they have, though there is some variation in what they think the color actually is, and sometimes they colorize it in a way that is meant to indicate certain things rather than reflect real color. The other experiment that I want to talk about is Marie, which was of course the Mars radiation environment experiment. Here we see a year and a half of its readings in orbit around Mars, not on the surface, but this is important so that we know what kind of radiation doses any potential Mars explorers might face. And the answer is that the base rate is about 3 times what they experience on the International Space Station. But you'll notice those huge spikes, and those are from solar flares, proton events from the sun, and those send out a huge wave of radiation that any astronauts will have to be protected from. Now again, these readings are from orbit, so this is not with the protection that might be provided by the thin Martian atmosphere. The atmosphere will provide some protection from radiation, and so that has to be taken into account as well. And with that, thank you for watching. Today in Space History, April 7th, the 2001 Mars Odyssey mission. The non-Kerbal Space Program footage was provided courtesy of NASA and especially the Jet Propulsion Laboratory, and I hope you enjoyed this video.